Hey guys, I am genuinely excited to talk to you about this today. We are looking at recursive and explicit formulas for sequences, okay? I did some problems like this with my niece for her homework a couple weeks ago, and I realized I don't have any videos on this, so here we are. I will link a full playlist with lots of videos related to this topic as well if you need some more. All right, we are looking at 4 sequences here. And you might be wondering, what makes these sequences and not just a random list of numbers? Well, the numbers are related to each other in some way. I'm either adding the same number, subtracting, multiplying, dividing. They're related to each other. They're not just random. So that's why they're considered a sequence. Now, the first thing I want to do when figuring these out is to figure out if these are arithmetic sequences or geometric sequences. Now, I have a whole video on this. I will link in the corner, but I'm also going to do it here. So I want to look at my first sequence here and figure out how these numbers are related. And when I look at them for a minute, I realize that I am subtracting 8 each time. You want to make sure that pattern continues. So hopefully you can see here that we're subtracting 8 each time. Now this ... just signifies that this sequence keeps going. It doesn't stop there. So since I am subtracting each time, that makes this an arithmetic sequence. If you are adding or subtracting, that is arithmetic. If you are multiplying or dividing, that's a geometric sequence. Okay, now you might be like, okay, we're a little bit into this video and I still don't really know what a recursive and an explicit formula are. Well, that's what I'm going to tell you now. So these are formulas that we use to find additional numbers in our sequence. The reason we have 2 is with the recursive formula, you need to know the number before to get your next number. If I want to know the 100th term in my sequence, I need to know the 99th, okay? The explicit formula is my personal favorite. And by the way, I'm not sure why it's called explicit. I feel a little awkward saying that, but there's no bad words, don't worry. But the explicit formula, you can pick any term, plug it in and find it, and you don't need to know the term before it. Now, if you're like, lady, I have no idea what you're talking about, stick with me, okay? So I want us to pretend for a second that we are looking for the next term in this sequence, okay? Now, as we talk about these, there's a little bit of terminology we need to talk about, and then it falls together pretty quickly. So oftentimes you will see n when we are talking about sequences. That is referring to the place in the sequence. So n equals 1 is the first number in the sequence. N equals 2 is the second place, the third place, the fourth place, and we keep going. When you have a with a little number here, a subscript, a sub 1, that is referring to the value of the number in the first spot, okay? Again, if you're like, what is she talking about? Stick with me, okay? Another thing you will often see is a with a sub n. That just means you can plug in whatever number you want for n. We're going to use that a lot as we write these formulas because we want someone to be able to use our formula and plug in whatever number they want, okay? So if you were looking for the 100th number in a sequence, you would write a sub 100 or whatever number you're looking for, all right? So with all of that lovely thing in mind, all of those lovely things in mind, I should say, we are going to pretend that we want to find the 5th number in this sequence. All right. So if I were to label these, this would be a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 is what we're looking for. Now, if this were an English class, we figured out that to get the next number, you just subtract 8, right? So if this were an English class, I could just write whatever number you want to find, take the one before it and subtract 8, right? English teacher would be like A plus. But this is math and we like to write things in math language. So how do I represent subtract 8 from the number before in math language? Well, let's figure that out. So if I were trying to find a sub 5, let's figure out what that would be. I would subtract 8, right? And I would end up with negative 10. But we want to make a formula. So if I were looking for that, what did I do? To find a sub 5, I took a sub 4 and subtracted 8, right? That's what I did. But how do I show that for any number you want to find? Well, how we show that is I say a sub n, which means whatever number you want to find in this sequence, you take the one before it. But how do we say that in math language? We say a sub n minus 1. Okay, isn't 4 5 minus 1? Yes. So that means whatever number you want, oh my gosh, guys, whatever number you want to find, take the one before it. And in this sequence, we are subtracting 8. Obviously, it'll be different for whatever ones you are doing. Guys, that is my recursive formula. Now, I know this one was a little worried. They'll go faster as we do more. Now, something that you do need to include is in order for this to be helpful to anyone, they need to know what the first term in the sequence is. So I just make a little note that a sub 1 is 22. And then they can go ahead and use that to find more terms. But you see how they need to know the term before to get it. We'll do explicit in a second where you don't need that, okay? But I want to get recursive pretty solid, so we're going to do these other recursives first. So let's look at this guy. I want to know if this is arithmetic or geometric. So when I look at it, I notice that we are multiplying by a -2 each time. So because we are multiplying, this is a geometric sequence, okay? Okay, so what am I doing? If I wanted to find the next term, I would take the one before it and multiply by -2, right? So how do I show that in math language? I say whatever number you want to find, a sub n, you take the one before it, a sub n minus 1, and in this case, we are multiplying by a -2. Oh my gosh, happy day. Look how fast that was. Again, to make this helpful for everybody or anybody that's using it, we need to tell them that the first term is 7. A sub 1 is 7. Okay, let's go ahead and look at this guy. So if I look at it for a second, oh, I wanted to use red. Did my kids take my red? Okay, we will use orange. Okay, what am I doing each time here? There's 2 ways I can think of this. So you could think of that I am dividing by 5 each time, right? Now you're like, that's what I am doing. How else can I think of that? Well, a lot of times when we're doing recursive and explicit formulas, we like to, instead of thinking of dividing, we like to think of it as multiplying by a fraction, which is really the same thing. So we are dividing by 5 each time, or you could also say we're timesing by 1/5. It's the same thing. So since we're dividing, or you could say multiplying by a fraction, this is a geometric sequence. And then let's go ahead and figure out our recursive formula. So we are multiplying by 1/5 each time. So whatever term you want to find, you need to take the one before it and multiply by 1/5. Right? So I'm going to say whatever number you want to find, take the number before it and multiply by 1/5. Bam, there we go. And then for it to be helpful, we need to tell people that the first term in this sequence is 625. Okay, happy day. All right, last recursive. What am I doing each time in this sequence? Look at it for a second. Okay, I am adding 8 each time. Add 8, add 8, add 8. Okay, so how do I show that in math language? Oh, I forgot to say, since we're adding, this is an arithmetic, right? So how do I say in math language, whatever one you want to find, take the one before it and add 8. I say, whatever number you want to find, a sub n, take the one before it and add 8. There we go. Okay. And I need to tell people that the first number in this sequence is -4. Look at that, guys. We just did 4 recursives. Oh my gosh. Okay, now we get to move to the explicit formulas. So as I already said, the recursives are great, right? But you have to know the term before. What if we were asked for the 500th term? I would have to figure out the 499th, right? And to figure out the 499th, I'd need to know the 498th. And anyways, we just have to figure them all out, right? And I don't know about you, but I don't have time for that. The explicit formula allows us to plug in whatever we want for n, and you don't have to know the number before it. But how do we find that? Well, that's what I'm going to show you. Okay, here's the thing. I'm going to show you the formulas, but I don't want you to just memorize these. Okay, you're like, you're a YouTube math person. Why do you care what I do? I want you to understand it. So don't just memorize them if you can help it. I mean, if you got to do what you got to do, but I'm going to explain it so that it hopefully makes sense so that you remember it without having to just have it memorized. Okay, so we're going to use these. So the first one we're doing is, sorry, hold on. Let's pretend this is real smooth. Okay, arithmetic. So we're going to look at this guy. Okay, hold on. Let me fold this again. Aren't you glad you stayed for this? Okay, so we are looking for our arithmetic explicit formula. Okay, so if we think about this, okay, again, imagine I am trying to figure out the 5th term. Well, I subtracted 8 how many times? To find the 5th term, I subtracted 8 1, 2, 3, 4 times, right? That's going to come in handy to know that in just a second. So for my explicit formula, I say whatever number you want to find, okay, a sub n, take the first number in the sequence. In this case, it's 22. And what are we doing? We are subtracting 8. This D stands for common difference. That's what we're doing each time, right? We are subtracting 8 each time. So I would subtract 8, but not just once, right? If I subtract it once, I get the next number, but where from there? How many times do I subtract 8? Well, you subtract 8 one less time than what number you want to find, right? When I wanted to find the 5th term, I subtracted 8 4 times. So how do I show that? Well, I just say you subtract 8 n minus 1 times, right? If you want to find the 10th term, you would subtract 8 9 times, or 10 minus 1, which is 9. Okay, isn't that cool? So this is my formula, but a lot of times we like to kind of clean it up, not have parentheses. So I'm going to distribute that -8 in and have a sub n equals 22 minus 8n plus 8. And then I'm going to continue to simplify that and get -8n plus 30. Look at that, you guys. Now you're probably like, great, but how do we know if it really works, right? So let's go ahead and check it. So let's go with that we're trying to find a sub 5 again, but pretend we don't know what it is, that we're using our explicit formula, okay? So if I want to know the 5th spot, I want to know where n equals 5. I'm going to plug it in here. So I plug in a sub 5 equals -8 times n, which is 5, plus 30. Okay, so I have a sub 5 equals -8 times 5 gives me -40. And then I add 30. And what does that give me? Oh my gosh, that gives me -10, yo. So we got the same. So that makes me feel confident. Guess what? I could plug in 100 and figure out the 100th term. I could plug in 500 and figure out the 500th term. Isn't that cool? Oh my gosh. That's pretty cool. So that was an arithmetic one. Let's see what happens with geometric. Now, before we move on to that, if you were thinking, well, why don't I need to say what the first term is? I mean, you could if you really wanted to, but it's built in right there into the formula. So someone could plug in 1 to figure out what the first term was if they wanted to. Okay. All right, let's go ahead and look at our geometric one. So here is, hold on, pretend this is smooth. Oh gosh. Here is our geometric explicit formula. But remember, we don't want to just memorize it. We want to know why we're doing what we're doing. So let's talk about it. Okay. So for whatever number we want to find, we're going to take the first number in the sequence, so 7, and we are going to times by our common ratio, which is the number we are multiplying each time. So I am going to multiply by -2. But again, I'm not just multiplying by -2 once. That would give me the -14, right? That would give me the next term. But what about all the rest of them? Well, that is where this power comes in. We are going to multiply by this how many times? Well, again, when I want to find the 5th one, how many times do I multiply? I multiply 1, 2, 3, 4 times. Again, I multiply 1 less than the place I want to find. So that's where the n minus 1 comes in. N minus 1. Okay, does that make sense? Let's go ahead and check it and make sure. So if I were to just figure this out by continuing the pattern, right, then my next number would be 112, right? -56 times -2 would give me 112. And let's make sure that when we plug it into this sequence, I get that. So if I want to find, hold on, I want to use black. Slytherin colors, sorry. A sub 5 is what we're looking for, right? Because this is A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. We're pretending we don't know it's 112. A sub 5, we believe, is going to be equal to 7 times -2 to the 5 minus 1 power. Okay? So A sub 5 equals 7 times -2 to the 4th power. Okay, doesn't that make sense? That's what we did. We multiplied by -2 4 times. Okay, so when I do that, I get A sub 5 equals 7 times -2 to the 4th power. You can work it out, plug it in your calculator. It ends up being 16. Okay. And then 7 times 16 gives me, guess what? 112. Woohoo! So I'm feeling confident. I can plug in whatever number I want for n. I can find the 50th term in that sequence if I want, just by plugging into that formula. Isn't that cool? Okay. We've got another geometric guy down here. So let's take another look at our geometric explicit formula. Okay. So whatever number you want to find, you take the first number in the sequence, in this case it's 625, and you multiply by the common ratio, which in this case we are multiplying by 1/5, right? Which is the same as dividing by 5. But how many times am I doing that? I am doing it, whatever number you want to find, you do it 1 less than that. Okay? There we go. There is that formula. But you know I'm going to want to check it. All right? So if I were looking for, where'd my black marker go? Here it is. Okay. If I were looking for the next term in this sequence, I would divide by 5 again, or times by 1/5. 5 divided by 5 is 1, right? So A sub 5 is 1. Let's make sure when we plug into this formula that we get that, okay? So, oh, I don't want to be off screen. Okay. So I am looking for where n equals 5. Okay. So A sub 5 equals 625 times 1/5 to the power of 5 minus 1. Okay, so a sub 5 equals 625 times 1/5 to the power of 4. Okay, now if you put this into your calculator, 1/5 to the 4th power, you are going to get 0.0016 for 1/5 to the 4th power. So we're multiplying that by 625. And you might be like, ugh, that doesn't look like a fun thing to solve. But guess what? It ends up just being a sub 5 equals 1. And if you're like, what? How did that become 1? Because 0.0016 as a fraction would be 1 over 625. Okay. And then when you times that by 625, they cancel and you end up with just 1. Okay. And we're very happy because guess what? 1 and 1. So I'm feeling confident that my formula is correct. Okay. All right. One more. If you are still here with me, bless you. You should eat a chocolate chip cookie or something. Okay. So we are back to arithmetic. So let's look at our arithmetic formula on my very official paper here. Okay. So we are adding 8 every time, right? So for whatever number you want to find, take the first number in your sequence and add the common difference. Add 8. How many times? One less time than whatever place you want to find. Okay. Now, we usually like to simplify that down, right? Get rid of our parentheses. So we're going to distribute that 8 in. So we have a sub n equals -4 plus 8n minus 8. There might be some teachers that are okay if you just leave it like this. Personally, I like to clean it up, but you know, you do you or what your teacher wants you to do. So this ends up being a sub n equals 8n minus 12. Okay. Lovely. And then I know you want to, we're going to check it. Okay. So if I wanted to know what a sub 5 was, we'd add 8 again, right? And get 28. And let's make sure that that works out here. Okay, am I going to have enough space? Hold on. Let me get this paper again. Hold on. Stick with me. We're still here. Okay, so I want to know the 5th place. What number is in the 5th place? So a sub 5 equals 8 times n, which is 5, minus 12. Okay, so then I get a sub 5 equals 40 minus 12. And guess what 40 minus 12 is, guys? 28. Okay, look, we did it. Oh my gosh. Okay, I hope this was helpful. And I will, as I already said, link a whole playlist where I've got a bunch more examples. If this was a bit too fast for you, I've got some more examples over there. I've also got when you're given the formula and you need to find the sequence. Exciting things happening. All right, if this helped you, hit the like button if you can, leave a comment if you can, and I will hopefully see you soon. Thanks.